In today's lesson, we're going to be solving equations, which means each one of these problems is going to have an actual equal sign. So we're not going to be done until our answer ends with x equals some number, or maybe multiple numbers, depending on the problem. So the first type of rational equation that we have is when we have a single fraction equals a single fraction. Like in this one, this is one single fraction, this is one single fraction. When that happens, we can just solve by cross multiplying. So we're going to take 3 times 4x plus 5, and then we're going to take 9 times x plus 1. When we distribute those, we get 12x plus 15 equals 9x plus 9. And then we're just solving the equation. So move the x's to one side to get 3x plus 15 equals 9, which means that 3x equals negative 6, x equals negative 2. But then once we have our solution, we need to double check that it is not an exclusion to our original problem. We do that by looking at the denominators, and we basically are asking ourselves, does negative 2 ever make a denominator 0? But no, the only two numbers that would make denominator 0, in this case, negative 1 would make the denominator 0. So we know x can't be negative 1. And in the second fraction, negative 5/4 would make the denominator 0. So x can't equal negative 5/4. So negative 2 is fine because it is not negative 1 and it is not negative 5/4. So let's try some more examples, but these get a little trickier. So we're going to take x times x plus 11, and we're going to take 3x times 2x minus 3, and we're going to distribute. This time we have a quadratic equation because we have x squared terms. And to solve quadratic equations, we need to make the equation equal 0. So I'm going to move everything, in this case, I'm going to move everything to the right side. So when I move that x squared over, I get 5x squared. And when I move 11x over, I'm going to get a negative 20x. And to solve a quadratic, we always start by trying to factor it. So for this one, we can factor out a GCF of 5x. And when we do that, we have x minus 4 left. So we get two solutions. When we set 5x equal to 0, we get the solution x equals 0. And when we set x minus 4 equal to 0, we get the solution x equals 4. We just have to make sure that neither one of those are exclusions to our original problem, but they aren't. We just double check that neither 0 or 4 would make the denominator equal 0, and they don't. Our two exclusions in this case would have been 3/2 and negative 11. So 0 and 4 are both fine, so we can move on to the next one. So we can cross multiply again here. We get 4x squared. And when we cross multiply the other way, we get negative 3x times 9 minus x. When I distribute that, I get negative 27x plus 3x squared. So once again, we have a quadratic, which means I need this equation to equal 0. I'm going to move the 3x squared over to the other side and add 27x over to make it equal 0. And this one is also factorable. We have a GCF of x. X plus 27 is left. And when we set each of those equal to 0, we get solutions of 0 and negative 27. In this case, 0 doesn't work because if I plug 0 into the original equation, 0 squared is 0, and we can't have a denominator equal 0. Or if we plugged it into the other one, negative 3 times 0 is 0, and that would make the denominator equal to 0. So anytime a number makes the denominator equal to 0, we can't allow that. So it does not count as one of our solutions. Let's do one more together. One more of these at least. So we're going to multiply to get x minus 1 times x minus 8. We'll have to FOIL that. And then the other way, we've got negative x times 3. So when we FOIL, we get x squared minus 8x minus 1x plus 8. And when I make everything equal 0 and combine my like terms, I get x squared minus 6x plus 8. So this time there's no GCF, but we can still solve by factoring. The two numbers that multiply to 8, multiply to 8 and add to negative 6 are negative 4 and negative 2, which means my two solutions, if I set those equal to 0, would be 4 and 2. So we just have to check to make sure neither one is an exclusion. And our only exclusion in this case is 1, because an answer of 1 would have made that denominator 0. So 4 is safe and 2 is also safe. Neither one of those make the denominator 0. So what do we do if we don't have a single fraction equals a single fraction? And we're actually going to solve this like we started solving addition and subtraction problems, by getting a common denominator. So in this case, if I was going to start by getting a common denominator between all three of those fractions, I would need to multiply the first fraction by 6. I would need to multiply the second fraction by x. And the third fraction also needs to get multiplied by 6. So let me write out what we have. We would have 18 over 6x plus 5x over 6x equals negative 12 over 6x. And so in this case, our goal is just to solve this equation. And so because our denominators match now, we can kind of ignore them because they are already equal to each other. So we can just kind of look at the numerator from here, and we have 18 plus 5x equals negative 12. And that's all we're solving. So subtract 18 from both sides, divide by 5, and we get a solution of negative 6. But we must check our answer. We make sure that negative 6 would never make the denominator 0, and it wouldn't. So it counts. It's a good solution. So next one. The first thing I would do in this case, two things really. I would rewrite that 5 as a 5 over 1. And in fact, I might go ahead and distribute that minus sign to that 5 also, because it's easier to work with plus signs than minus signs. So let's just distribute that over. And I would go ahead and factor x squared minus 1 into x plus 1 and x minus 1. That's a difference of squares. So just like on the previous problem, we are going to find a common denominator here. And our common denominator, we need an x plus 1 and an x minus 1. Which means for this first fraction, we need to multiply by an x plus 1. The second fraction has neither of those, so we're going to have to multiply by both, an x plus 1 and an x minus 1. So what we have, our denominators match now, so we can kind of ignore them. So our first numerator is a 7x plus 7 when I distribute. My second numerator, let me take another step first. So I have negative 5, and then when I have x plus 1 times x minus 1, that's just x squared minus 1 when we FOIL. So when I multiply that by negative 5, I get negative 5x squared plus 5, and then equals 6. We can ignore the denominator at this point because our denominators are already equal. So now we're just solving the numerator. So let me combine some things a little bit. We've got negative 5x squared, a 7x, and a 12. But I really don't like my x squared term being negative, so I'm going to go ahead and move everything to the right side of the equation. So when I do that, I get a positive 5x squared, a negative 7x, and a negative 6. And to solve this, I need a factor. So I am looking for two numbers that multiply to negative 30 and add to negative 7. And those, of course, would be negative 10 and positive 3. I need to go ahead. I cheated in the beginning by multiplying that 6 by 5. So now I need to uncheat by dividing by 5. So my two factors are x minus 2 and 5x plus 3. Which means my two solutions, when I set those equal to 0, I end up getting x equals 2 and x equals negative 3/5. I just have to make sure that neither one of those are exclusions. Do either one of them make the denominator 0? And you can kind of look at our denominators here. It's a little bit easier where everything's factored. The only exclusions we have is x cannot be negative 1 or positive 1. So both of these are safe. So another example, pretty similar. We'll just do a couple more. So I'm going to factor first, and then I'm going to get my common denominator. So in this case, our common denominator is going to need to include an x plus 2 and an x minus 2. And I'm going to go ahead, because this is a subtraction problem, I'm going to go ahead and change it to an addition problem and move that into the 4x as a negative. So when I get a common denominator, this first fraction, we're going to need to multiply by x plus 2 over x plus 2. Second fraction is good, and the last one needs an x minus 2 over x minus 2. So all of our denominators match. We're going to focus on the numerators. So when I distribute the 6, I get 6x plus 12 equals 8x squared minus 4x squared plus 8x. So all we're doing there is distributing our numerators. We're just solving the numerator at this point. And now, because it's a quadratic, I need to make it equal 0. So I'm going to do some combining like terms here. I'm going to move this 6x over to make 2x. And I'm going to subtract this 12 over. And then there is a GCF here. Let me go ahead and pull out a 2. But to continue factoring this, I am going to have to cheat a little bit. So I'm going to do x squared plus x minus 12. So two numbers that multiply to negative 12 and add to 1. And I multiplied by 2, so I have to go through and undo that step. So in my factored answer is 2 times x plus 2 times 2x minus 3. But if I set each one of those equal to 0, my solutions are negative 2 and 3/2. So in this case, 3/2 is a solution, but negative 2 is not, because that's one of our exclusions. If I plugged a negative 2 in right here, for example, I would get a 0 in the denominator. And we can't have a 0 in the denominator. So x equals negative 2 does not work, but x equals 3 over 2 does. Let's just we'll do one or two more. So starting off by factoring this first fraction, I've got a GCF of n squared. And to get a common denominator, I'm going to need to multiply this middle one by n squared over n squared. And I'm going to need to multiply this last one by n plus 5 over n plus 5. So now all of our denominators match. They all have an n squared and an n plus 5 in them. So now I'm focusing on the numerators, and I just need to solve. I need to distribute, and I need to solve. So when I subtract this 5 over, I get 0 as my constant. So just 4n squared plus n. So that means I have a GCF of n I can pull out. And so my two solutions, when I set each one of those equal to 0, I get a 0 and I get a -1/4. Check for exclusions. -1/4 is good. 0 doesn't work because if I plug in a 0 right here, 0 squared is 0. And I would have a 0 in the denominator. So 0 cannot work because it would make the denominator equal to 0. So I'll do one more example, but this one is similar to another one that we already did. I'm just going to spread it out a little bit because our goal is to get common denominators. And in this case, our common denominator is going to need an n+1 and an n+8. So that means our first fraction needs an n+1. Our second one needs both an n+1 and an n+8. And our last fraction needs an n+8. So again, our goal was to make all the denominators the same. So now all of our denominators match. They all have an n+1 and an n+8. So we can kind of ignore them because they match. And we just are going to solve our numerators now. I'm going to rewrite it before I start distributing. So I'm going to have to FOIL that first one. I'm going to have to FOIL this one too. And for the third fraction, we'll just distribute that 6. So when I FOIL, I'm going to get n squared plus 1n plus 5n. That makes a plus 6n plus 5. When I FOIL here, I'm going to get n squared plus 8n plus 1n is a plus 9n plus 8. And then distribute the 6 to get 6n plus 48. So it looks like a quadratic, but actually, if I subtract the n squared from both sides, they cancel each other out. So this is just a linear equation. So we need all of our n's on one side and our constant on the other. So let's see, I've got 15n on this side, and I can subtract this 6n from this 6n, and those cancel out too. So let's see. Let me combine what I've got. I've got 5 equals 9n plus 8 and 48 make 56. So when I subtract 56 from both sides, I'm going to move out over here to the side. -51 equals 9n, which means n is -51 over 9. That's not a super pretty solution, but it can be reduced to -17/3. And that is not an exclusion. So that's a good answer. My only exclusions here are -1 and -8. N can't be -1, N can't be -8. So don't forget to check your solutions to see if we have exclusions there. And really, when we're doing these problems, it's very much like adding and subtracting rational expressions. Just get the common denominator like you would normally, but then ignore the denominators because we're actually solving these. And when we solve them, we only need to look in the numerator. So because there's an equal sign, we're solving. You're not done until you have x equals or n equals a number.